Hello, everyone, and thanks for joining me again today. Today on my agenda is drakon renderer again, combined with our lexical analyzer generated with Alex, and also my naive parser that I wrote some months ago and modified slightly yesterday. I'm very tempted to not just go ahead or to just go ahead and start playing with parser generators because I'm dying for a formal syntax for Wyvern, which is the code name for simplified drakon. But I think I'll just exercise my strong will, and I'll just stick to that naive parser for the moment. So I hope you're having a drink of your choice ready. I have my coffee prepared that I've just made right now. And let's write some code. By the way, where you live, it's a beautiful summer day, yet another one. So I'm enjoying every minute of it. Now, back to business. I would like to see what the parser used to look like. So here we have a title. So what we need to do now is to devise an algorithm that will go through a list of these tokens and parse each and every one of them. So for now, the assumption is, and I'll write it down in the parser, today is the 19th. One D list of no forks, no addresses. That will later. So having said that, it would be good to keep iterating through it. So let's see what this parse function has to offer for us. So this function, parse skewer blocks, is responsible for handling TS. I don't believe it's used now. So let's provide an alternative for it. I will learn how to use that one day. Parse skewer blocks, and the input to our parser is a list of tuples, the token meaning, and the token name, and the token value. So for now, And here, this is already an indication of promising start. We're returning not a drakon diagram, but a list of skewer blocks. That is good. So this is right. And for now, let's just return all right. So just for now, let's return this. And also the end. I hope this is right. So we return a list of skewer blocks, but also it is a part of a tuple, and the second element of a tuple is a remaining list of tokens. Let's assume for now that this can drain that whole collection of tokens and not leave anything behind here for the color function, which is going to be this. So we leave this alone. And drawing inspiration from this, and here we don't care about this collection. I'm sure there's an expression for it. something like tail. There used to be a nice illustration in this book about that, and I have a oh yeah, here. In it last. Okay, let's see if we have access to it. And here, oh, I must have closed it. Let's see how much time it will take us to rebuild it. If it takes a significant amount of time, I'll just take a break here and we'll return later. All right, 42. Ooh. So because this is a different type, we can't do that. Okay, not to worry. I can just make it up. And this is all skewer blocks. But we still need the list around it. Okay, let's see. Maybe you remember yesterday we commented out HLint from Cabal build, or from the build script. Let's see if we can restore it. Does it work? HLint not found. I used to have a comment here about HLint. I'll have to fix it one day. But for now, I think we can live without HLint. What counts is that it builds. think we'll have to just take it slow for the moment, as there are many problems with this code. Oops, nope. It's changed. That's good. But this isn't really parsing. Yes. So what we need is to just keep parsing, parse skewer blocks. We have that already. So we have a loop, combine and parse skewer block. So this will be simplified a little bit. So for now, let's assume that all skewer blocks are of the same type. They are all actions. So this one should be simple. No skewer block tokens provided. Okay. Now, and here, we'll just match the number of tokens. So here we don't even need a case. So here we don't even need to worry about this case. Our skewer block. Yeah, this is where the list would end, but we don't care about that for now. And it breaks. Let's see. Ah. It builds, but doesn't build for the right reasons. I think I made a mistake here. I shouldn't have changed that. So let's restart this. And we'll have to modify the types slightly. So this is a list of tuples. And this also needs to change. This needs to change. And this needs to change. And also, this needs to change. And this needs to change. So we go from this type, return from parse skewer block prime to the input of this input of loop is which is identical. That's good. And now combine. Oh, this needs to return tuples as well. So parse skewer blocks prime. Nope, still not happy. 47. I'm not using that code, am I? Oh, I need to remove it because the loop and combine change signatures. 81. And of course, I need to get rid of this. We need to return this when the iteration stops, or is supposed to stop. Combine, okay. So we need to return nothing from this, I believe. Yes. Okay. Sorry. Oh, sorry. In our case, this is justified not to return left, just right. And we can return left if we can't parse. So for now, this is fine. That took a while. Custom content action. Okay, perfect. So we're calling this. So now we just need to extract content from these actions. Well, that is not ideal. Let's see what's happening there. Oh, we're skipping T. Can we do this? Yeah. Beautiful. So now the trick is that the end terminator in the input is also treated as a valid skewer block, which will correct. Let's do this. Hello world exclamation end. Okay, this is not too bad. Let's enable troubleshooting mode. Okay. This is really not helping these positions. These all get -1. Okay. So now we don't need this. And I'm going to leave this just in case, because we have a nice nested logic here, which could become handy. So here it would be something like this. TS off. If this is the last element, sorry, we also need an X. So that is an X. And also this will be right string something. Let's see. And in this case, yeah, some problems with my light here. Nope, it doesn't work with me. And otherwise, of course, we need that X. For now, let's just leave it as it is. So this should just skip the last element. It's not minus, it's underscore. So this should disappear now. And it does. So the only thing we need to do here is to write a function called would this work? parse and terminator. Finish terminator. That's end terminator. And that needs to be a string. Tuple. Let's just call it x. So here we don't need to worry about this for now. Ooh, okay, so this will be not so fast. Case of we need to return right just and terminator with an empty list of tokens. And that would be x with this, I believe. Ooh. we can't do this here because the types need to be consistent. Okay. Let's undo all of these changes. Or not. Let's copy that code. It will be needed somewhere else. Or a similar version of it will be needed. Okay, let's copy the loop. So here we need to give it init. So we still expect the icon 6 to be gone. Icon 6 meaning a terminator. And it is. Well, when I say icon, I also mean the skewer block. And now we do parse and terminator with last of TS. So we'll have to do but if it's right, then we simply do this should work. Perfect. All right. So we have a simple 1D primitive diagrams, sort of parsable. They're not ideal because we treat content as the entire token, or we treat token as the entire content. We don't extract values out of the token, but we'll get there. I think I'm pretty happy with this for today. Ooh. One D. So I'm pretty happy with this. Right. During the next session, we'll probably do a mix of either the work on forks and more complicated chunks of skewer blocks, or we'll try to extract values from the tokens provided as the skewer blocks or a determinator, standard determinator, etc. But the work will definitely be parser oriented. Right, having said that, I would like to thank you all very much for your attention today. I wish you have a fantastic day. Take care of yourselves, and I'll see you next time. Bye.